Chapter 6.2 Transformers and High Voltage Transmission. A transformer can change the combination of voltage V and current I of an alternating current. It is widely used to provide different voltages to different electrical appliances. 1. How a transformer works. A transformer basically has two coils, with an iron core passing through them as shown in Figure 6.2b. Current flows in the primary coil produces a magnetic field. When the primary current changes, the magnetic flux experienced by the secondary coil changes, which induces a secondary current. The soft iron core improves the magnetic flux linkage between the coils by reducing the leakage of magnetic flux, so that the electrical power is transmitted from the primary to the secondary coil more efficiently. Let's take a look of the experiment 6C for the demonstration.
In this experiment, we will construct a simple transformer and study how the transformer works. First, wind 10 turns of wire around a C-core as the primary coil and 25 turns of wire around another C-core as the secondary coil. Clip the two C-cores together. The 10-turn coil is connected to a switch and a battery box. And the 25-turn coil to a center zero galvanometer. Close the switch and then open it. How does the pointer of the galvanometer deflect? Now connect the primary coil to an AC power supply and the secondary coil to a 2.5 volt lamp. Connect another 2.5 volt lamp to the power supply. Switch on the power supply. How is the brightness of the two lamps different from each other? Next, a 2,400 turn coil is used as the primary coil. Put it around one arm of a U-core. Connect the coil to an AC power supply. Connect a 2-meter wire to a 2.5 volt lamp. Switch on the power supply. Wind the long wire turn by turn for at least 28 turns around the other arm of the U-core. How does the brightness of the lamp change?
When the battery box, which is a DC source, is connected, there is an induced secondary current only when the switch is open or closed. When AC source is used, we can see that there is an induced current in the secondary coil when the primary current changes, and the lamp becomes brighter when the secondary coil has more turns. Such effect of electromagnetic induction between two neighboring coils is called mutual inductance. When the switch is closed, the primary current produces a magnetic field in the anticlockwise direction. The secondary coil experiences the change in magnetic flux and induces a current to produce a magnetic field in the opposite direction. Hence, a secondary coil flows from the top to the bottom through the ammeter. And then the primary coil stops growing stronger, and so no more secondary current flows. When the switch is open, the magnetic field produced by the primary current decays rapidly. The induced current in the secondary coil flows to restore the decaying magnetic field, and thus produces magnetic field in the anti-clockwise direction. Current flows from the bottom to the top through the ammeter, and then there's no more primary current flows, and so there's no more secondary current flows. When an alternating current flows in the primary coil, the magnetic field in the coil keeps changing continuously. There will be an induced EMF in the secondary coil of the same frequency as the primary current, which readily drives a current through a resistor, which is called a load resistor. Now please try check point 4 on the next page.